Dear students, welcome to today's class. Today I am going to explain types of functions. Yesterday class also I have explained a few types of functions. They are one function, onto function, bijection and even function, odd functions, like that I explained. Today we are going to see some more functions. That is, one is a inverse function, second one is polynomial function, algebraic function, transcendental function. In transcendental we will get a exponential function, logarithmic function, trigonometric function, inverse trigonometric function. Here we will get rational function, here real variable function, real valued function, real function. Okay na? So now we are going to explain these functions in today's class. Okay na? So let us start our class. Let us discuss what is a inverse function. Already we learned about inverse relation. Okay now, just I will explain about inverse relation. So if R is a relation, that is a 1, 2, 2, 3, 3, 4, some 7, 8, then its R inverse is given by 2, 1, 3, 2, 4, 3, 8, 7. So R inverse means, so we will interchange the ordered pairs. That is a simple definition of inverse relation. Now coming to inverse function means, for example, you take one example. So this is equal to A, B. Two sets, let us take A is 1, 2, 3, here A, B, C, D, E, F. 1 is mapped onto A, 2 is mapped onto B, 3 is mapped onto C, 4 is mapped onto D. Clearly, F is a function from A to B, and moreover it is 1 function. Moreover, it is a 1 function. Very nice. Now, we will think of that reverse process. Is this a function from B to A? B to A, it is a function. Let us think about that. Is it a function from B to A? No. Why? Because here the elements A and F does not have any image in A. That means the elements from B to A, the elements A and F does not have any images in A. That's why from B to A it is not a function. From B to A it is not a function. Let us see another example. A, B. So F is a function 1, 2, 3, 4, 5, 6. 1 is mapped onto 2, 2 is mapped onto 3, 4 is mapped onto so. Clearly F is a function from A to B, and moreover function from A to B, moreover it is an onto function. It is an onto function. Okay now. Let us think that is it a function from A to B? Sorry, B to A. Is it a function from B to A? No. Why? Because the elements 5 and have two images, 1 and 2. The elements 5 has two images, 1 and 2. Therefore, from B to A, it is not a function. B to A, it is not a function. So, from this, what the conclusion we get, if a function from A to B, there is no need to that from B to A is also a function. If F from A to B is an onto function, there is no rule that from B to A is also a function. But when it from B to A is also a function. So let us take one example here. A, B, here 1, 2, 3, 5, 6, 7. 1 is mapped onto 2, 2 is mapped onto 3 is mapped onto 2. F is a function from A to B. Okay now. So clearly F is a bijection. F from A to B is 1 function. A to B is onto function. Then if you write from B to A is also a function. Why? 5 has the element 1, image 1, 6 has the image 2, 7 has the image 3. Therefore, from B to A is also a function. It is denoted by, so what is our main function? F from A to B. From B to A function, the notation is F inverse. Understand? So don't think that F inverse is not equal to 1 by F. It is a notation, that's all, a function name. That function name is given as F inverse. Understand that? That means what? If F from A to B is a bijection, f from a to b is a bijection, that is both 1 1 and onto. Then from b to a is also a function which is called inverse function of the function f from a to b. It is denoted as f inverse from b to a. From this, what can you conclusion we can get? Here, to have a inverse function, the number of elements in A should be equal to the number of elements in B. Okay, now that is the main point you have to remember. And the domain of f is equal to the codomain of f inverse. The codomain of f is equal to the domain of f inverse. Okay, now so let us see some more points from inverse function. Okay. Here we are going to see a working rule to find the inverse of a function. Okay. So, how to find out a inverse of a function means, let us take that a and b are two function, f is a function from a to b, and let x is an element, your image is f of x, your image is f of x. Okay, now so dear students, let f from a to b is a bijection, let x belongs to the set A, and automatically then as per the notation f of x belongs to b. Since f from a to b is a bijection, then f inverse from b to a is also a function, that is called inverse function. Okay, now. So see the very important notation I am saying. If your element is x, under the function f, your image is f of x. Set. Now there is a new function from b to a. So let us call it your element in the domain B. In the domain B is y. Under this brand f inverse, its image is f inverse of y. F inverse of y. If x is an element under the image f, brand name f of x, your element is y, under the brand name f inverse, this is f inverse of y. That means in the codomain, all elements are either of the form f of x or y. Therefore, f of x is equal to y implies x is equal to f inverse of y. So, this is a very important notation that you have to remember. So, f of x is equal to y, or y is equal to f of x, then x is equal to f inverse of y, or f inverse of y is equal to x. Understand? So, to find the inverse of a function, first of all we have to check whether the function is a 1 1 or not. Okay? And after that we will proceed according to this procedure. Now, let us take one small example here. So, let us take a function f from R to R be defined as f of x is equal to 2x plus 3. It is a function. So, clearly it is a linear function, therefore, all linear functions are 1 1 and onto. Okay, now I already told to find out the how to find out onto function. So here, so what you have to take, as soon as it is given notation, immediately you have to remember this is R to R, your element is x, your image is 2x plus 3. This is called f of x. Let us call it as y. That means y is equal to f of x. Y is equal to f of x. What is your f of x? 2x plus 3. That means 2x plus 3 is equal to y. From this, x is equal to y minus 3 by 2. X is equal to, what is your x? What is your x? F inverse of y. So, in place of x, I will write down f inverse of y is equal to y minus 3 by 2. Therefore, actually, this is your inverse function. But whatever be the straight function or inverse function, there is a rule that we represent the functions in the variables x. That's why f inverse of x is equal to x minus 3 upon 2. So, this is your inverse function. Whatever may be the function given, first immediately you call it as a y. Y is equal to function given 2x plus 3 or e power x or log x or whatever may be the function given, right. So, after that write it as a subject of x. Subject of x, x is equal to y minus 3 upon 2. Okay, now, then afterwards in place of x, substitute f inverse of y, then afterwards finally you convert it into x. Okay, now, so this is a procedure working rule to find the inverse of a function. Now, let us see the graphical approach, then how the graphs of the original function and its inverse function. Original function, its function, how it will be graph. Let us see that. Okay, now, right. Now dear students, let us see the graphical approach of this inverse function. So what is the graphical approach? That means whatever may be the function f of x function and f inverse of x function, these two curves, if you draw the curves, they are symmetrical about symmetrical about the line y is equal to x. Symmetrical about the line y is equal to x. Let us see one example. F of x is equal to a power x. F of x is equal to a power x, right? It's the inverse function. So what is how to find out inverse function? Let y is equal to f of x is equal to a power x. Therefore, a power x is equal to y, x is equal to log y to the base a. Therefore, f inverse of x is equal to log x to the base a. That means your function is f of x is equal to a power x and its inverse function is log x to the base a. Yes, obviously you see that their graphs. So if you see the graphs, so this is a y is equal to a power x graph. Y is equal to a power x and it is a y is equal to log x to the base a graph. If you see this, these two graphs are symmetric about y is equal to x line. Y is equal to x line. Okay, na? Right. So whatever will be the graph, if it is a virginal function, if it is a y is equal to f of x function, this is f inverse of function. Both are symmetric about the line y is equal to x. Symmetric about the lines y is equal to x. Whatever may be the graph will come out up and down, both are symmetric. Understand this? Okay, na? So I hope that you understand this concept, inverse function concept. So let us go for next concept. Dear students, now I am going to explain the polynomial function and algebraic function. So generally students will get confused between the polynomial function and algebraic function. So to know about this polynomial function, first of all, you should know what is a polynomial. What is a polynomial? So the polynomial is, for example, x cube plus 3x square minus 2x plus 5. It is a polynomial. That means the coefficients 1, 3, minus 2, 5, they should be real numbers. They should be real numbers. And the powers, whatever may be that 3, 2, 1, here x power 0, they are whole numbers. Whole numbers. Actually, to be speaking, whole numbers. Then that is called a polynomial. Now, see here, x plus 1 by x is a polynomial? No, it is not a polynomial. Why? Here the power degree is 1, but here the degree is minus 1. It is not a polynomial. Is it root x plus 3x plus 5 is a polynomial? No, it is not a polynomial. Why? What is the exponent of x here? 1 by 2. Therefore, it is also not a polynomial. So, therefore, polynomial function means f of x is equal to anything x power 4 minus 2x square plus 3x plus 5, as it is a polynomial function. Again, 2y plus 3y square plus 7 f of y, as it is also a polynomial. That means these coefficients, no, there should be either rational number or irrational number. For example, root 2x square minus 3 by 2x plus 1 by 5, as it is also a polynomial function. So these terms should be either separated from plus or minus. The powers of the variable, whatever may be the variable, should be a whole number, either 0, 1, 2, 3, 4, 5, like that. Okay. The coefficients may be either rational numbers or irrational numbers. Understand this? So this is type of functions are called polynomial functions. What is algebraic function? Be careful that. So algebraic function means all functions will come, that is equal to root x plus x power 3 by 2 minus 3 by 2 root x. This is a algebraic function. And f of x is equal to root of sin x plus sin inverse of x. This is also an algebraic, so this is not algebraic function. So this is equal to 3 by 2 root x plus 1 by 2x plus 7. This is also an algebraic function. And one more thing, f of x is equal to 3x power 4 minus 2x cube plus 3x plus 8. This is also an algebraic function. So from this, what can you say? All polynomial functions are algebraic functions, but all algebraic functions need not be polynomial functions. All polynomial functions are algebraic functions. All algebraic functions are need not be polynomial functions. Understand this clear? That means what? Algebraic functions means what? All will come, all mixed. Root x, x power 3 by 2, 3 by 2 root x, root of sin x, whatever may be the mixing, all the things you will get. Understand this? So those are called algebraic functions. Understand? So only these powers are integers. That means only positive integers, 0 or positive integers, 0 or positive integers. That means whole numbers. They are called polynomial function. Understand this? I hope that you understand these two functions clearly. Okay, now? Dear students, we are going to see what is meant by transcendental function. So these are quite opposite of algebraic functions. That means the functions which are not algebraic functions. Both are quite opposite. The functions which are not algebraic, they are called transcendental functions. So we have 4 types of transcendental functions, that is exponential function, logarithmic function, trigonometric functions, inverse trigonometric functions. So you know that this exponential function is e power x, a power x, whatever may be that, all will comes under this exponential functions. Right? Logarithmic functions, all that, log x to the base a, ln x to the base e, all types of log x to the power of a power x, or log x, or log of sin x. All these are all called logarithmic functions, and they are comes under transcendental functions. Okay, coming to trigonometric functions, as everybody knows what is trigonometric functions. F of x is equal to sin x, cos x, tan x, cosecant x, secant x, cot x, again sin of 2x plus 3, sin of 6x plus 5, all comes under trigonometric functions. Now inverse trigonometric functions, as this also everybody knows, f of x is equal to sin inverse of x, cos inverse of x, tan inverse of x, cosecant inverse of x, cot inverse of x, all comes under inverse trigonometric functions, but the both are quite opposite. So here transcendental functions and algebraic functions, the functions which are not algebraic functions, okay, they are called transcendental functions. See here all these are transcendental function. And sum of the exponential and this also, for example, wherever if we have f of x is equal to e power x plus a power x, this is also called as exponential function. Again trigonometric function also, for example, if f of x is equal to sin 2x plus cos x, yes, this is also called as a trigonometric functions. And the inverse trigonometric functions, all these 4, 1, 2, 3, 4, these comes under transcendental function. Okay, now, so I hope that you understand this concept. Okay, let us go for next concept. Dear students, while learning types of functions, better you learn all these 3 functions at a time. So one is a real valued function, real variable function, real function. So very easy one. So let us take a function f from a to b. Let us take a function f from a to b. A and b both are subsets. But here, if b is subset or equal to R, that means the set B contains the numbers, set of real numbers, then it is called real valued function. For example, a and b, f is a function. For suppose f contains the names of the persons, Ramu, Gopi, Sita. Okay, here B contains their roll numbers 1, 2, 3, 4, 5 like this. Ramu roll number is 2, Gopi roll number is 1, Sita roll number is 3. Understand this? This type of functions are called real valued functions. Real valued functions. Understand? That means the set contains anything, whatever may be the names of the person, maybe numbers, whatever may be that. If the set A contains anything, any elements, but the set B should be the subset of R, then this type of functions are called real valued function. Okay, now quite opposite real variable function. If A is subset or equal to R, then it is called a real variable function. For example, here school fees, here student's name. For example, school fee 1000, first term fees 950. So here Ramu, Gopi, Sita, some numbers are there, school fees. Okay, Ramu paid 1000 rupees paid by Gopi, 1500 paid by Sita, and 915 paid by Ramu, like this. That means what? The set A contains set of real numbers, all numbers, whatever may be that numbers, and B may be anything, Such type of sets are functions are called as real variable function. Understand this? Right. Next, what is a real function? This is a mixing of both real valued and real variable function. That is, both A is subset or equal to R, B is also, that means F from R to R. This type of functions are called real functions. All functions generally we come across are real functions only. All functions, whatever may be the functions we come across, those are all real functions only, unless otherwise stated. For example, in the problem, let f of x is equal to some, he call it as some 2x plus 3. If we say that f of x is equal to x plus 3, that unless otherwise stated, this is a real function R to R. We have to think like that. If it has any one particular function is there, then he will give that thing. Okay, now, right. So, while learning these three functions, let us learn clear. So, real variable means A subset of is equal to R. Real valued means B subset R is equal to R. If both are subset are equal to R, then they are called real function. Okay, now, right. I hope that you understand this concept. Let us go for next type. Dear students, let us learn one more function, that is a rational function. Okay. So, to know about these rational functions, let us learn what is a rational number. So, as any number of the form p by q, where q not equal to 0 and p, q are integers, they are called rational numbers. For example, 2 by 3, minus 2 by 3, all are rational numbers. Here also, rational function means a function of the form f of x by g of x, where of course g of x is not equal to 0. F of x upon g of x, the denominator g of x is not equal to 0. That type of functions are called rational functions. We can give so many examples. For example, x square minus 2x plus 3 upon x square minus 2x plus 7, as it is a rational function. Anything f of x is equal to e power x by sin x, it is also a rational function. Numerator by denominator, of course sin x should not be equal to 0. Understand this? So, this type of functions are called rational functions. Okay, numerator by denominator type functions are called rational function. The condition is denominator should not be equal to 0. It should not be equal to 0. Okay, na? Q should not be equal. It should not be equal to 0. If it is equal to 0, definitely the function cannot be defined. Okay, na? So, dear students, I hope that you understand this today's types of functions. And the next class also we will have different types of functions, such just like a very important types of functions, that is a modulus function, greatest integer function, and the fractional part functions are very important. Actually, comparatively these functions, thus modulus function, greatest integer function, fractional part function, these functions are very important. Why? Because you will get a number of questions involved in these greatest integer functions. Okay, na? Not only in this function chapter, in calculus also you will come across this greatest integer function and fractional part function and modulus function. Okay, that we will see in the next class. Okay, I hope that you understand this today's class. Let us meet in the next class.